Question 2. Time-of-flight mass spectrometry can be used to analyze large molecules. P, which is a large molecule, is ionized by electrospray ionization, and its mass spectrum is shown in figure 2. So its mass divided by charge, we'll assume its charge is +1, so its mass is 556. So mass divided by charge, mass divided by 1 is 556, so its mass is 556 of this P plus ion. In electrospray, the P will gain an H plus, so it'll actually be PH plus, and that will be that ion there. Give an equation to represent the ionization of P in this process and describe the process of electrospray ionization. So 3 marks to explain electrospray ionization. First of all, you dissolve it in a solvent. The solvent is usually methanol or water. Best to be a polar solvent with delta plus and delta minuses on it, like methanol or water, and volatile means that it's got a low boiling point. The sample is then injected down a capillary tube. It comes out the end of a capillary tube. A capillary tube or a capillary needle is a very, very, very fine needle, and it comes out as a mist. So when it comes out under pressure and is converted into a mist, and then a very high voltage is applied to the end of it, and that's when it gets the H plus. Another word for an H plus ion is a proton. The equation then is P. It's got to be a gas. It's coming out as a gas, a very fine mist. So it's coming out as a gas. So P, G for gas. It gains an H plus or a proton and turns into PH plus when it gains the H plus, and again it's a gas. What is the relative mass of P? Well, H is got a mass 1, so H plus, where it's lost an electron. Electron doesn't weigh anything, or it's negligible, the weight of an electron, so it's a mass of 1. Take away an electron, which is negligible. That has got a mass of 1. So before it is 556, take away 1. So the mass of the P before it's gained the H pluses, which has got a mass of 1, is 556. Take away 1 is 555. A molecule Q is ionized by electron impact in a time-of-flight mass spectrometer. The Q plus ion has a kinetic energy of 2.09 times 10 to the minus 15 joules. This ion takes 1.23 times 10 to the minus 5 seconds to reach the detector. Length of the tube is in 1.5 meters. So this is correct in terms of units. Kinetic energy should be in joules, time should be in seconds, and the length of flight should be in meters. So it's all in the correct units here. Kinetic energy is half mv squared. So we're given that equation where m equals mass in kilograms and v equals speed in meters per second to the minus 1. Avogadro's constant 6.022 times 10 to the power 23. Give the relative molecular mass of Q. So, first of all, we're given the kinetic energy and we're given this equation. We want to try and work out m for mass. So therefore we need v squared. So we've got kinetic energy, we've got v squared, we can work out m and solve this problem here. V squared, well, velocity is another word for speed, so velocity is distance divided by time. We've got the distance, or the length of the tube, is 1.5. We've got the time used to reach the detector, so therefore we can work out v, or the velocity, which equals 1.5 divided by 1.2 times 10 to the minus 5 is the velocity. 12195.1.22. It's got a very high velocity, which is correct. Therefore, now I've got kinetic energy, which is 2.09 times 10 to the minus 15 equals half times m. I don't know m, that's what I'm trying to find out, multiplied by the velocity v squared. So that's 12195.1.22 squared. Solve those two, so mass is 4.18 times 10 to the minus 15 once I've multiplied both sides by 2 to get rid of the half, and then divide by 12195.1.22 squared. It comes out as 281 times 10 to the minus 25. It tells you here it's the mass in kilograms. Now if I'm going to work out moles, mass of 1 mole, which is the MR, therefore I need the mass in grams. So kilograms down into a lower unit value of grams, I multiply by 1,000, so 2.81 times 10 to the minus 25 multiplied by 1,000 is 2.81 times 10 to the minus 22. So if I have 1 mole, moles equals mass divided by mR. 1 mole is the mR. So mR is the mass of a particle, 281 times 10 to the minus 22, multiplied by Avogadro's constant, because that's the mass of one particle, therefore multiplied by the number of particles in a mole, and therefore it comes out as 169. So that's the mass of the particles in 1 mole, which is equal to the mR. 169, I've put it to 3 significant figures, because the rest of the numbers, 1.23, 1.50, 2.09, are to 3 significant figures.